Our video presentation focuses on corrosion prevention measures for material durability and longevity, demonstrating how strategies extend lifespan and ensure structural integrity with a clear narrative and extensive visual. The objective of this report is to develop and implement effective corrosion prevention measures to enhance the durability and longevity of materials and structures. This involves understanding the various factors contributing to corrosion and applying suitable strategies to mitigate its effect.
In this experiment, the base material is carbon steel, well used and easily accessible. The primary corrosion risk is uniform corrosion due to exposure to moisture and oxygen, which cause rust formation. Outdoor factors like sunlight, rain, high humidity and rapid temperature fluctuations accelerate this process. Indoor, while humidity is lower, ambient moisture and temperature change can still pose a corrosion risk. To mitigate corrosion, we choose an anti-rust primer film as our protective coating. This primer forms a physical barrier that prevents water, oxygen and chemical from contacting the metal surface. It offers several advantages. Easy to apply and cost-effective compared to galvanization, catalytic protection and corrosion-resistant alloy. Quick dry with press dry within 30 to 45 minutes, enabling efficient application. Moreover, some primers, especially zinc-based type, can penetrate the metal surface, adding further resistance.
I had like to briefly explain how we carry out our rust prevention test. First, we clean all the carbon steel nails to remove any rust or dirt. Then we apply a protective primer to some of them while leaving the rest uncoated. We divided the nails into two groups. One kept outdoors in natural condition and the other kept indoors in natural condition, and also other nails kept indoors in shelter area. All this was done to see how well the primer would protect against rust in different environments. After a few days of observation, we found a clear difference. The uncoated nails, especially those that kept outside, started to show rust quickly, while the prime nails remained nearly rust-free. The indoor nails were less affected overall, but the protective coating made a big improvement in preventing corrosion. So this simple and cost-effective method successfully keep the metal from rusting, extending its life in both outdoor and indoor conditions.
A2. This one is sample A. Sample A no coating placed outside, shown that this is rust spot appear. Okay. While for sample B, painted placed in the outside, shown that no change. Okay, this is sample C. No coating placed in the inside, which is shown that slight discoloration, like that. So for sample D, painted in the inside, shown that this is no change. For outdoor, the uncoating nail rust more clearly, with the coating nail stay clean and shiny. The coating helps protect it from rust. Both nail indoor did not rust badly, but the uncoating nail turned slightly black and show a bit of rust. Day 6. For sample A that have no coating, placed at the outside, show that this have a moderated rustic. B, which is painted, placed at the outside, show that this have minimal surface roughness. C, no coating, placed in the inside, show that this is have a rust spot. And then for sample D, painted, placed in the inside, show that this is have no change. A. So this is sample A, no coating placed at the outside, show that it has heavy rust at the surface. Okay. For sample B, painted, placed at the outside, show that it has minimal surface roughness and have a small rust at this area. For sample C, no coating placed in the inside show that these have minimal rust spots. Okay. For sample D, painted, placed in the inside show that these have no change.
As mentioned before, in this experiment, 4 nails were placed in different conditions to observe how fast they rust. Sample A, which had no coating and was left outside, rust the fastest. By day 2, rust appeared, and by day 16, the surface was badly damaged with thick and flaky rust. This is because outdoor conditions, sunlight, rain, and air speed up the rusting process. The changes between wet and dry and UV rays from the sunlight cause the metal to break down more quickly. Sample B was painted and also placed outside. It lasts longer with no rust until later. By day 16, there was only a little bubbling and rust at the edges. The paint worked as a barrier, stopping the air and moisture from touching the metal. But because of sun and rain, tiny cracks may have formed, especially around the edges. This allowed rust to start underneath. Sample C, uncoated, were placed indoors, rust slowly. There was only a slight rust because the indoor space had no rain, strong sunlight, or big temperature changes. This helped slow down rust even without paint. Sample D, coated and kept indoors, showed the best result. The paint stayed in good shape and blocked air and moisture, keeping the nail clean and free from rust. This shows how important both coating and environment are in stopping rust. The more a metal is exposed to water, air, and sunlight, the faster it will rust. For better result, it is recommended to use stronger lasting coatings that can resist cracking and still protect even if scratched. Good surface preparation and reapplying paint over time also help protect metal better.
Conclusion, the experiment provides the anti-rust coating and environmental control are highly effective in reducing corrosion. The uncoated outdoor sample show the most survive corrosion, while the coated indoor sample that the best resistance. This confirms that protective coating, when properly applied, can significantly extend the lifespan of metal. Combining coating with suitable environmental condition is the key effective corrosion prevention.